Hi, it's Mike from the Parker Store. In this Partner with Parker Store video, we're going to talk about hydraulic hose failures, the most common things that go wrong with hoses, the likely causes, and how to address each of these situations. It should be noted that even in optimal conditions, and in cases where hose assemblies were properly made, the life expectancy of any hose assembly is directly related to the operating parameters of the application. But when a hose fails, it is often the result of some form of human error, misapplication, improper usage, or improper maintenance. Let's look at some of the most common hydraulic hose issues. First off, you've got your burst hose, where the wire reinforcement failed in the braid along the outside of the hose. This can happen when a hose has simply lived out its service life, but it can also be the result of a high number of pressure cycles or a continuous flexing of the hose in that one area. There's nothing to do here but review the application, replace the assembly, and develop a preventative maintenance schedule. Here's another kind of burst hose, where it bursts near the fitting, along with signs of corroded wire, but with no obvious cover damage. You'll see the hose leaks that could look like a pinhole, or maybe just an escape of moisture called weepage, or there might be bubbles near the fitting, which may contain fluid. This happens when the hose inner tube was cut or damaged during the fitting assembly, possibly due to a lack of proper lubrication. When the fitting is improperly assembled like that, it allows moisture to enter around the socket of the fitting, which corrodes reinforcement wires. You got to replace the hose assembly, making sure you review proper assembly techniques. Sometimes you see hoses like this one, which has burst at the fitting, along with broken wires at the last shell grip, or sometimes at the end of the nipple. This happens when the hose continuously moves or pulls at the fitting. Excessive movement may be the result of pressure surges, or the hose assembly length being too short, or the hose bend may begin too close to the fitting. Yet another cause may be incorrect crimp dimension. Fix it by lengthening or rerouting the assembly to allow for some slack. Never stretch to fit, as assemblies may shorten when pressurized. Before starting to bend it, the hose should be routed straight for at least 2 times the inside diameter of the hose. Clamp the assembly as necessary to avoid movement. Review crimping techniques and proper tooling. Next issue, when the fitting blows off. This occurs when the hose wasn't inserted into the shell of the fitting per the recommended length, which means all the grips aren't being used. All the grips in the shell are needed to hold the fitting onto the hose. In fact, the last grip in the shell does about 1/4 of the work in holding the fitting to the hose. In such cases, you simply have to replace the hose assembly. And before inserting the fitting, make sure you mark the cover of the hose per the recommended value stated in our catalog. Then insert the fitting to the end of the shell lines up to your mark. Okay, now here's another way the fitting can blow off, when the assembly leaks between the shell of the fitting and the hose. This can happen when the shell of the fitting is either under or over the recommended crimp specifications. You just got to replace the hose assembly, checking for proper fitting usage. And make sure you review the crimping instructions for the particular crimper being used, including proper tooling. Now sometimes you'll get external damage to the hose cover. The hose actually bursts around an area where there's an obvious twist in the hose. You'll also see some broken wires. This occurs when the hose gets an unwanted twist during the assembly of the fitting due to a lack of proper lubrication. You have to review proper hose assembly procedures and replace the hose assembly. You may also have to use clamps to reroute the hose, using the hose ley line as a guide to assure that the hose flexes in one plane. Okay, here's a case where the cover has foreign object damage and/or abrasion. Reinforcement wires show signs of being rubbed and possibly torn and corroded. This is from excessive rubbing or chafing of the hose against an external object, possibly other hoses or the wrong size clamp, or perhaps from the impact of the hose on sharp corners or brackets. This calls for replacing the hose assembly. Use a protective sleeve or hose guards. Reroute the hose assembly, and if appropriate, use proper sized clamps to avoid contact with other objects. Sometimes when fluid is emitted at a high velocity from an orifice and hits the inner tube, erosion happens, and eventually the inner tube is gouged through to the wire braid for several inches, causing the hose to spring a big leak. The erosion can also be caused by particles in the fluid, but the cause here might still be traced to the hose assembly, like if it's bent too tightly for proper flow, or if the fluid medium is too abrasive for that particular inner tube. In any case, you got to replace the hose assembly. Next issue on our list, when the hose bore appears to be restricted. The tube may be torn or may have broken loose from the reinforcement and piled up at the end of the assembly, resulting in a reduced flow or maybe no flow at all. In these cases, the outside of the hose may show signs of being flattened. This comes down to vacuum failure. The hose may have been kinked, flattened, or bent too sharply in some cases. It may be due to poor adhesion or insufficient cure of the inner tube. Replace with a hose rated for the specific vacuum application. Sometimes pressure issues cause a hose to burst, maybe in a number of places. These are usually clean bursts with no random wire breakage and no sign of wire-on-wire abrasion or cover abrasion. This is usually caused by excessive pressure or pressure in the range of the minimum burst rating for the hose. You can adjust the system pressure to be within the established working pressure of the hose or replace with a hose with a higher working pressure than the system pressure. And don't forget to include pressure spikes when choosing the PSI of your hose. Then there are the effects of cold. Hoses exposed to temperatures below their recommended limits during hose movement. What you'll see is the inner tube and/or the cover has cracks, but it's soft and flexible at room temperature. To address this issue, review the application and raise the temperature to within the boundary specified, or replace with a hose recommended for the given temperature parameters. Conversely, there are heat-caused issues. The hose will be hard, brittle, and crack when flexed at room temperature. On its cover, there may be visible signs of being dried out and charred. So in these cases, you know that the hose was exposed to heat in excess of the recommended value. What's happened is aerated oils have caused oxidation in the hose's inner tube, making the hose harden. Any combination of oxygen and heat will accelerate the hardening of the inner tube. The same effect may be caused by cavitation, the formation of empty spaces within the material. Plus, plain old age can also create these symptoms. If your hose isn't near or beyond its service life, review the application and lower the temperature to within your hose's working limits, or replace the hose with one that has a qualified temperature rating. Install heat guards or shields as required. If you find that your hose's inner tube contains numerous fine cracks, yet remains flexible and no cracks are found in the hose under the fittings, then the internal air may be too dry, probably due to the use of a lube-free compressor or a refrigerated air drying system. Replace this hose assembly with one that is rated for extreme dry air. Fluid can also be incompatible with just the inner tube, which can badly deteriorate the inner tube as you see here. It may also show signs of swelling and delamination. In some cases, the inner tube may be partially washed out. Again, you need to replace the hose assembly with a hose that's compatible with the fluid to be used, or replace the fluid with one that is compatible with the hose material. Check out our stamp video for additional information on selecting the right hose for your specific application. If you have any questions about assembly techniques or bending, talk to your Parker Store professional or find our hose installation and routing video on YouTube. Also, talk to your Parker Store professional about extending the life of the hose in your application. If you're looking for sleeving options, your Parker Store professional can help you get the best protection for your hose. I hope this video has helped you in your understanding of how hose issues are caused, how to address them, or better yet, avoid them altogether. We hope also that it's clear how crucial it is to ensure you have the correct hose assembly, and that it's set up in the proper manner. Remember, you can always turn to the pros at your Parker Store. They'll make sure you have the product that's right for your application and answer any questions you might have.